Hi everyone, my name is Srinjoy Majumdar. I'm a software engineer at Microsoft working on mixed reality commercialization. And today I'm going to be talking to you about a new app that we developed called Quality Fundamentals. So Quality Fundamentals is a HoloLens 2 application that demonstrates the fundamentals of a great mixed reality experience. And we built it in the context of designing a bicycle factory. So as the user starts their own bicycle factory, they'll go through all the fundamentals of building mixed reality and seeing sort of the common performance issues you may hit while building an application and potential solutions. You can download it in the Microsoft Store, so you can go to the Microsoft Store, search Quality Fundamentals, and then you should be able to download it on your HoloLens 2 device, or you can click on this link once we share out these slides. So the motivation behind building this app is actually driven by some of the onsites that we've had with our ISVs over the years. So a common theme that we saw emerging through those onsites was that new mixed reality developers didn't quite understand what a great mixed reality experience looks like. So with 2D applications, it's really easy. You just expect buttons to be responding, expect it to be rendering at frame rate. But in mixed reality, there's a whole new set of factors to keep in mind when developing your application. And we really wanted to take all of those lessons that we've learned over these on-site engagements and put them into this application so that users can experience these issues and solutions in an interactive way on device in a much more immersive way than you would by just reading documentation. So before I move into the content of the presentation, there's three more resources that I want to mention. The first is Designing Holograms, which is another HoloLens 2 application that our design team developed just about a few months ago. And this app really goes over some of the new design paradigms that are there in mixed reality. So like hand tracking, spatial mesh, and all sorts of things like that, and how you can incorporate those into your app to build a really great experience. So I highly recommend checking that app out as well. Quality Fundamentals is a bit more focused on once you integrate those design paradigms into your app, how do you now get it performing as you would expect and making sure that it's performing the best it can be for your users. The Microsoft documentation website is another fantastic resource for any questions with mixed reality development and HoloLens development. You'll notice actually most of the content that we cover in the app and even in the presentation today comes from this documentation website. The only difference is that the app is sort of this immersive way of experiencing what we talk about in the documentation. So definitely a great quick resource. The final thing is the Microsoft Partner Network. So if you are developing an application and you're wanting to take it to your customers, Microsoft Partner Network is a great set of resources, of people, of documentation, and just Microsoft being able to work with you to essentially deploy your solution to your customers. So all three are great resources to keep in mind. So today we're going to be talking about the four main modules in the application, and I'll sort of give an overview of the lessons that we covered in the app and some of the technical reasoning behind why we decided to show those lessons, and then we'll go from there. So the first module that we're going to be covering is Device I/O and Environment. Device I/O and Environment is essentially focused on all of the environmental considerations to keep in mind before you even develop your application. So you might be wondering, why is the device environment even important? You know, in 2D application development, you're probably not always thinking about, oh, where is my app going to be deployed? Where is the user going to be using it? But with mixed reality, it becomes much more important because the way HoloLens knows to place holograms and keep them in place is by tracking you in your space. And it tracks you by essentially extracting unique landmarks from what it's seeing around you, and it remembers those so that it can understand where you are and then show the same content when you come back to it. Now, the issue is if you don't have an environment where you have very many unique environmental landmarks, then the HoloLens is going to struggle to maintain the position of these holograms and sort of persisted across time if you come back to the same location. So that's why it's really important to make sure that your environment is well featured, which means that there's a lot of unique interesting things that the cameras can pick up on so it can recognize where you are and maintain tracking. So in this picture here, you can see on the left, we have sort of the color RGB image, and on the right, you can see sort of the features that one could extract from that. And you can see it's sort of the corners and all the unique areas where there's more contrast or colors. These are sort of the things that the device picks up on and can recognize when you come back to it. So the way we demonstrate this in the app is by first putting the user in this factory environment. And you'll notice that there's nothing in the factory so far. The floors and walls are blank essentially. And the first thing we imagine the user would want to do is see sort of this holographic representation of how they could start building out their workbench. So first thing they do is drag this workbench to this possible location, and they can start to see the measurements of what this workbench would look like. However, once they do this, the device actually starts to struggle to remember where you placed it, like which box you placed it in. And this is happening because even though the yellow and black tape may seem like a great source of unique environmental landmarks, it's actually repeated throughout the factory. So you see we have just one box here, we have a second box, and a third box. And as a result, if you were to try and start your device in one of the other areas of the factory where you have the same pattern, the device might get confused and place the wrong hologram there. This is especially important if you don't have very many features to begin with in the rest of your environment. So you can see here we have gray walls and gray floors. So really the only thing it can pick up on is this yellow and black tape. And since this is repeated throughout the factory, you're going to start to see issues with that. So in general, we recommend avoiding repeating patterns if you're in a very low featured area. The second issue you'll see is that we have blank floors here. And this is a relatively easy fix in a factory environment like this. Something with more texture and putting up safety signs and even things like we've done putting up silly spray throughout the floor. Anything that adds more texture and unique landmarks to the floor can really help the device maintain tracking, even in challenging environments like this. And the same goes for the walls. If you just have very plain walls and nothing on them, and you're seeing some issues with device tracking, we recommend putting up some unique posters. So you can see here when the user clicks this, we put up some unique HoloLens posters on the wall. Yours can be anything you want. It can be safety posters, whatever. As long as it's unique and it's kind of providing more unique environmental landmarks for the device, it's going to help with tracking. The next two are slightly less common, but just as important, and you'll notice that sometimes the HoloLens might struggle with mirror finishes and glass. So you'll see here, we've actually now went ahead and built the workstation after seeing the holograms. So this is sort of the actual workbench we've decided to place in our factory, and you'll see that the top is this metal reflective sensor. And sometimes you might see some issues with the device not being able to place holograms super accurately because it's getting confused by the reflections on the table. Again, this isn't very common, but it might be an issue if you don't have very many features in the rest of your environment. So if you're seeing issues like that, we recommend just swapping it out with like a matte material, and that should definitely make the tracking performance much better. And the same goes for glass, especially in an environment like this. If the reflections from the glass and the fact that it's actually a very dark color can cause some issues with our spatial mesh system and our tracking systems. So in situations like this, again, if you're noticing some tracking issues, you can put blinds up over the windows, and that can create a more controlled environment for the device to be able to maintain tracking across sessions, across time. So those are kind of the surfaces that we cover in the application. And the next big thing we cover related to the environment is sort of lighting challenges. So in terms of lighting, a very common question we get all the time is, how much light do I need in my environment for the HoloLens to be able to maintain tracking? And we struggle to give a solid answer to this because it's up to so many factors, and it's really hard to pinpoint it down to an exact number where your tracking is going to start to work. But our general guidance is that a good place to start is around 500 to 1000 lux. So if you have a lux meter or a mobile app, you can use that to measure the light level in your space and see if it's around that value. And if it is, then lighting probably isn't the issue if you're facing other problems. So we demonstrate this in the app. So the user has a IoT smart panel that pops up in the factory, and they drop the lighting in the warehouse. And once they do, you can see that the device loses tracking. So if you don't have enough light, the HoloLens is not going to be able to recognize features, and is again going to struggle with tracking in those situations. Again, slightly less common, but just as important situation we've seen before is the device losing tracking in areas with really high dynamic range. So this is when there's really sharp changes in lighting. So there's like really bright spots and really dark spots in your scene at the same time. So for example, we've seen here, the warehouse, we open the windows and the sun starts to stream in and you have this really bright spots in front of you and this really dim spots for the rest of the warehouse behind you. And as a result, you end up blowing out one of the areas because we can't expose the both. And as a result, you're not going to be able to have as many features as you would expect, and the device is probably going to lose track. So again, the solution is similar to what we mentioned for glass, which is if you can have some blinds on these windows or whatever is causing sort of the bright light to appear in your environment, that can really help maintain a more controlled environment for the HoloLens and ensure it can track across multiple sessions. So that's sort of the big things we cover in the environmental section. Again, just making sure that you're minimizing the number of challenging surfaces and making sure that you have a good amount of lighting and consistent lighting in your space is really going to help your app perform the best it can in once it's deployed for your customers. So the next thing that we cover in the application is spatial anchors. So spatial anchors are required for precise positioning of holograms. So if you place a hologram relative to sort of a physical landmark, and then you walk around and you come back and you want it to stay in the same place, it's really useful to be able to place that anchor there because the device will prioritize making sure that that piece of content stays in the correct location. The other advantage of placing anchors is that if your device does lose tracking at any point while you're operating in the app, once you regain tracking, any content that was anchored should hopefully just snap back to the correct place. And we demonstrate this in the app. So again, now we're back in the factory and the user has sort of already built a physical version of the first workbench and they're seeing the holograms for what a second version of this workbench could look like. And they're going to again place this workbench into the location. And you'll notice we've anchored the shelves in the toolbox. So if you see those red anchors on top of the holograms, and we haven't anchored the desk. So once we dim the lights and we lose tracking, you'll notice that the desk does not return to the correct location. So it's kind of on top of your head, but the shelves and the toolbox are in the correct location. And this is sort of the behavior you would see if you don't place anchors on content and then you end up losing tracking. So highly recommend placing anchors for any content that you would want to persist. Now that we've established that we want to place anchors, the actual placement or the location of anchors is a slightly more nuanced topic. So the first thing to keep in mind is that your anchors should be near the holograms that they're trying to sort of ground. So we demonstrate this again with this workbench here. You'll notice that it's a little bit hard to see, but if you look closely, there's a red anchor a little bit further away, and we just have one for sort of this whole hologram here, which has the shelves, the desk, and the toolbox, and we have this anchor pretty far away from it. And as a result, the content isn't quite positioned correctly in the box. And that's because you're seeing some drift from the anchor being far away from the content because the device is trying to make sure that the location where the anchor is actually the optimized grounded area. But if your content ends up being very far away from the anchor, there's going to be artifacts that you wouldn't expect there. So in contrast, we have the user clicks with the improved version. Now they can see that we've placed anchors for each one of the holograms and we've placed it much closer to the actual geometry. And as a result, now the whole hologram looks much more in line with where it should be. Now, this is an extreme representation, but usually we recommend keeping your geometry within a few meters of the anchor that you're trying to use to locate it. Now, this is one thing, but the other area where you can start to see this drift is if you actually have just one hologram, but a very large hologram. So in this case now, the user wants to place a conveyor in their factory. So they walk up to this QR code and they locate this conveyor in the factory, but you'll notice that it almost stretches from one end of the factory to the other. As a result, just using one anchor is still causing drift on the very far end of the conveyor, and it's not quite positioned correctly in the box again. So in situations like this, we recommend placing multiple anchors. Even though it's just one object, we recommend placing multiple anchors to sort of help it maintain its position throughout the physical space. So you can use packages like the mixed reality world locking tools, where it'll automatically interpolate between the various anchors you place to lock large objects like this into your world. And that should definitely help keep the large objects in your scene more aligned. And you can see here, once we placed the two anchors, it sort of snapped back into the correct place. Now you'll notice when I walked up to that QR code, the conveyor automatically popped up in the right place. And this is actually one of the easiest ways to do sort of a co-location experience, which is a common request. So if you walk up to the QR code and you've already sort of saved where the geometry should appear relative to that QR code, you can obviously see the geometry when you walk up, but another person with another HoloLens can run your app and see the same content. And now you can sort of be in a co-located experience where you're both pointing at the same geometry and work together in a collaborative sense. This looks great if you have the ability to put QR codes in your location, but if you don't, then we recommend something called Azure Spatial Increase, which is a service that we have to essentially persist the anchors that you're placing into the cloud. And the great thing about this is that now anyone can recall that anchor on their HoloLens device, even if they haven't seen the environment before. And it's not just even limited to HoloLens devices. People can actually use our ASA SDKs on iPad, iPhone, Android, and be able to essentially locate these anchors from any of the other devices, and you can sort of be in this co-located experience using Azure Spatial Increase. So we highly recommend that if you don't have the ability to place QR codes or just want a more easier experience to get started with experiences like this. All right, so that covers everything with spatial anchoring. The next module that we cover is hologram stability. And in hologram stability, we're mainly focused on performance factors that can affect essentially the rendering of holograms. So the first thing that we cover is the frame rate in your application. And the main thing to keep in mind with HoloLens development is we highly recommend your app render at 60 frames per second at all times. So a common misconception I think here is that app developers get confused on why 60 frames per second is such a big deal, because in 2D application development, when your app is rendering at 60 frames per second versus 30 frames per second, there isn't a huge difference. You're going to see the frame rate be a little bit more choppy, but usually your experiences are still just as fluid, and you're not seeing any slowdown in the system. But in mixed reality, when your application starts rendering at 30 frames per second, not only is your app rendering at 30 FPS, but so is our stabilization system and our system UI and all sorts of these other things that go into the experience. And when they don't render at 60 FPS, it can really make it more uncomfortable for your user who's using the app. So this is really hard to demonstrate, especially if your app's always been rendering at 30 FPS without seeing an app that actually renders at 60 FPS. So when you go into this stability module, the first thing we show you is this bicycle cog that's unoptimized, which has almost a million triangles, which causes the app to render at 30 FPS, and you start to see all these artifacts and our stabilization systems. The experience just isn't as smooth as you would expect. And then when you go to this optimized cog, which has only 16,000 triangles, you see the app render at 60 FPS. And you can very clearly see the difference in experience across these two modes. And that should hopefully show you how big of a difference it can make when your app is rendering at frame rate. Now, the solution to this is unfortunately not that simple. What you have to do to sort of make sure your app is rendering at 60 FPS is profile throughout the development process. So you don't want to just profile at the end because it might be too late at that point. You might have several pieces of unoptimized codes or unoptimized assets. We highly recommend just profiling from the start of your application development cycle, and that'll really help make sure that you're always hitting 60 frames per second. And if there is a regression, cache that and optimize that before you sort of get to the state where it's almost impossible to do. So again, highly recommend making sure your app is rendering at 60 frames per second. The next thing that we cover is late stage reprojection. So this is sort of our device's system for stabilizing holograms as you're moving around quickly. And the first thing to keep in mind is that this system uses the depth buffer. And as a result, you really want to make sure that any opaque objects in your scene are writing to the depth buffer. To do this on Unity, you can easily check if your app is or your material is writing to depth, and the same can be done on Unreal or any other game engine. And you want to make sure that any opaque material is writing to depth. And for any transparent materials, it's optional. You might see better performance actually without it writing to depth. But again, I recommend trying it out yourself and seeing what kind of difference it makes. If you're writing to depth buffer, that should automatically make your app start to feel much more stable. Now, the other thing to consider is if you do have geometry where you're using transparent rendering. So for example, in this scene now, the user is sort of in this fixing the bicycle stage. So they've got this checklist of things to do for the bicycle, but you'll notice that the checklist actually doesn't have no background. There's a couple of consequences to this. First, the HoloLens is a mixed reality device. So if you're not rendering a backplate on something, it's going to essentially be rendered on whatever the background of the user is. So it might work great if the user has a dark background where they're looking right now. But if they're looking at a white wall and you have a white checklist or text on your checklist, it's going to be really hard for them to read. So that's just a design consideration in terms of the rendering of transparent UI. But it can also actually start to cause some issues for our late stage reprojection system because it's continuously adjusting between the near text and the far background. And as a result, you might just start to see some artifacts around the text that you wouldn't otherwise expect. So the solution for this is pretty simple. We recommend just putting opaque backplates on any text that you're rendering, and that should definitely make it easier, not just for your user, because they can read it much more easily, but also for our the reprojection system to be able to avoid artifacts around the text. The final thing I want to mention is we actually have 3 different LSR modes, or late stage reprojection modes. So the first is depth late stage reprojection, depth LSR. This is on by default, and this is the one we recommend for most users and most applications. But the alternative that we have is actually called auto-planar reprojection. And this mode might be slightly better for applications that have a lot of sharp changes in depth. So if you have, actually this application is a great example of this. If you have sort of really close content with the menu and really far content with the background of the warehouse, auto-planar reprojection might end up being a little bit better. The only way to truly know is to try it out for your specific app. And the great thing about this is that you can actually toggle the mode without changing any code through the Windows device portal. So if you go to the device portal, the hologram stability page, you'll be able to toggle between the different LSR modes through that. And in the quality fundamentals application, actually, we give the users the option to toggle between autoplanar and depth LSR and see the experience differences in our app, actually. So that's a great way to try it out as well. The final 2 things that we cover as performance factors are sort of more classical video game programming issues that you might have run into. And I actually had to record this video with the HoloLens because you might actually not see this issue crop up on like your game editor or Unity or Unreal, but then you might see this happen on the HoloLens. So it can be really confusing. So here's what it looks like for z-threading. So in this case, the user is now placing this sort of decal on their bike, which was one of the steps on the checklist. And once they do, you'll notice that as I walk up to the bicycle, the decal disappears. And when I come back, it appears again. This can be a really confusing thing to debug. And the problem usually in cases like this is that actually the decal and the bike are at the exact same depth value. So as a result now, when we're trying to render the geometry, Unity doesn't really, or your game engine doesn't really know which one to render first, so you'll start to see artifacts like this. The solution for this is very simple. All you need to do is make sure that your decal is offset from the bike by a little bit, and then Unity is going to have a much easier time understanding how to render the content, and it's going to be on top at all times. So you can see here, we just offset it just by a little bit, and now you'll see even on device, it seems to always be at the correct location. So something to keep in mind with HoloLens development. The other common issue that we see is aliasing. So this can be in the form of text aliasing, or sort of thin and high contrast geometry can also cause this issue. So you'll see this checklist in this lesson is actually, we switched out the text from Unity's Text Mesh Pro, which uses pre-rendered text, to just the default Unity text. And you'll start to see that actually the text looks a lot worse. It's shimmering and it's not looking great. So this is the default Unity text. And then we give the option to toggle back to the pre-rendered text. And you can see once we do that, it looks much better, it's more clear, and it's much easier to read small fonts like this. We also show this through the spokes on the bicycle. So you can see here, we've used some really thin and high contrast bicycle spokes here. And on the HoloLens, it's almost impossible to see this geometry because it's so thin. And you'll start to see it kind of do the same shimmering effect, which is a sign of aliasing. And the fix for this is relatively simple as well. You just can use some, thicker geometry for device for the HoloLens device, and that should make it much more clear when you're seeing it. So yeah, looks much better and is much more clear, even though it might have looked almost the same in your editor. So those are sort of the four big factors that we cover in hologram stability. There's more factors as well, but these are sort of the most common ones we've seen in our engagements, and we think that if you can address these, it should go a long way in making sure your app is performing as optimally as possible for your users. So the final module that we cover is 3D asset fundamentals, and in this section, we sort of go over a basic overview of how to optimize some of the geometry in your application. So the first big thing to keep in mind with 3D asset fundamentals is triangle count. So HoloLens is a mobile rendering device essentially, and as such, it is limited in how many triangles it can display before performance starts to degrade. And we demonstrate this sort of in this final showcase scenario, where now you've built your bike, you've got your factory, and we're in this marketing scenario now, where we're showing you how it's possible to render this bike in a very nice sort of marketing scene. And the user can actually choose to click on a button and add more variants of their bike to the scene. As they do, we're essentially bumping up the triangle count in the scene. And as they do that, you start to see the frame rate slowly drop down, especially depending on sort of the shader you're using and all of these factors. So you can sort of play around with the settings and see what happens when you add more bikes to your scene and the triangle count goes up. So this is a great way of visualizing the performance impact as the triangle count goes up. And we often get the request for like, how many triangles is the limit on the HoloLens? And again, this is very dependent on your device. So it's hard for us to just give you a number because it can really depend on how many shaders or what type of shaders you're using, how many draw calls you have. And all of those factors can really impact that number there. So it's really on an app by app basis. So we recommend profiling your application once again from the beginning. And as you're adding these assets, looking at what is the limiting factor. So Unity has a built-in profiler. And with that, you can see if the CPU is the bottleneck or if the GPU is the bottleneck, which is usually a great starting point. If you're seeing the CPU is a bottleneck, it's usually some issue in your game script. But if you're seeing the GPU is the bottleneck, it's probably you're trying to render too many triangles or you're having issues with your shaders. So definitely recommend profiling as often as possible for this. The other thing we have is actually shader complexity. So again, this is hard to demonstrate through the slides, so it's best to see this on the app itself, but you can actually, we give the users the option to toggle between the MRTK standard shader and the Unity shader and see sort of performance impact on that. We recommend using the MRTK standard shader for optimal performance because it's essentially been optimized for the HoloLens and for mobile rendering. Essentially allows you to achieve almost the exact same visual effects you would get with the Unity shader, except it's a much more performant version for HoloLens. So we recommend doing that. And if we also recommend minimizing the number of shaders you're actually using in your device. So if you're saying that you're using lots of different shaders, you're going to start to see your performance quickly degrade on HoloLens because it's not really meant for that. It's really meant for a few shaders and using as many material instances as possible to keep sort of the overhead down and keep your app running smoothly. That being said, if you have content that just isn't fitting this triangle count, is has lots of details, you want to render it at full resolution, we do have an alternative, which is using our Azure Remote Rendering service. So this almost eliminates these sort of asset limitations by rendering all of the content in the cloud and then streaming it down to your device. The great thing about this is essentially you have almost an unlimited number of polygons that you can render, and you can render it down to your device as long as you have a stable internet connection. And that can be great for situations where you want to see the full detail. So in industries like construction or healthcare, it can be really important to see every single detail in the model, and Azure Remote Rendering can enable those situations for your application. So definitely recommend checking that out as well. So this is the final lesson that we show in the lesson in the app. This is where you can see like the difference between using one draw call versus many draw calls. Again, it's hard to show on this slide, so I just have a picture. But if you went to the application, you'll see the difference, and you'll be able to see the frame rate drop down and go back up and use just one material. So that's everything we have in quality fundamentals. I hope you enjoyed our quick primer of this. Again, this presentation is just a quick snapshot of what we cover in the app. I highly recommend going to the store and downloading it yourself to try it out. And if you have any feedback, feel free to reach out to me with any improvements that we can do for the app. We really want to make sure that it's the best showcase of what's possible with the HoloLens, and it covers any potential issues that you faced and solutions for those. Thank you.